So this morning, we're going to look at linear programming modeling, something that we started already. So we'll be looking at linear programming modeling. Then when we are done, we're going to look at probability distribution. So I'm going to combine two lectures, lecture 4, lecture 5 today, okay? Having said that, last week we concluded that, again, beyond using matrices, we can also use other methodologies to find the solution for our decision variables. And we looked at how we can use graph to solve our problem. We agreed that with a graph, because we have only x and y axis, we can only solve a linear programming problem or a linear equation problem when we have only two decision variables, i.e., when you have x1 and x2. Having said that, sometimes you may be having complex problems and even matrices can't give you accurate decision or accurate solution. You may end up doing a lot of things. So we can also adopt either using a method called simplex method for solving linear programs, or we can also develop, we formulate a problem, then we use computer to solve the problem and also interpret the results. So our quest this morning is to look at how to use the computer to build a set of formulation, then used an application called Solver within Excel to provide answers. What most computer applications do for you is to give you the output of whatever data that you have instructed the software to do. So ours is to interpret the output of the report. So when we are using the computer and we finish our formulation, the next thing to do is to now analyze the results. So that is what we'll be doing this morning quickly. So I'm expected to let you understand at the end of this session, simplex method, computer solutions of linear programming, then interpretation of computer-generated reports. For this semester, we are not treating the simplex method because of the Zoom and all that. Would have wished we can meet one-on-one to treat the simplex method. So I'm skipping the simplest method of solving linear programming problem, and we'll concentrate on the computer solutions of LP problem. Means that we are looking at how to use matrix to solve linear equation problem, how to use graph to solve linear equation problem, and how to use the computer also to solve for linear equation problem. That is what we are going to look at for this semester. So what we are going to do is that just a review of what we did with a graph. I'll just look at this question. At this juncture, we all know how to formulate a linear programming problem, okay? So, and as I concluded last time, that in formulating a linear programming problem, you look out for 4 main components, okay? You are looking for how to formulate the decision variables. From there, you identify the objective function. After the objective function, you move on to the resource constraints, then the non-negativity constraint. This is a repetition throughout anytime you have a problem that has to do with linear programming method, okay? So let's look at this example. We'll go through quickly. This example has to do with how to use the graph. We've already talked about the graph. No, we talked about the graph the last time, okay? So I'm not going to waste time. This example is basically helping us to do something on the simplex method. And as I said, I'm not treating simplex method. So I'm jumping slide 1 all the way to, I think, slide 25 and continue with the computer solution. So please note that. Please note that. So we are here. using the computer to solve a linear programming problem. I'm going to read this question. We will formulate it manually. Then when we finish, we'll use the Excel to formulate it. After the formulation, then we solve for the problem. We take the output and interpret the output. So I need you to follow along the line. Okay, good. So can somebody read it for us? Just raise your hands and I'll call you if you want to read the question for us. Angela Bentum. Okay, so Angela, please read the question for us.
Okay, thank you. Solving linear programming. Solving LPS, computer solution. A phone dealer is preparing to make new orders for phone types Nokia, Samsung, and LG. The unit profits for Nokia, Samsung, and LG are 100 Ghana cedis, 300 Ghana cedis, and 50 Ghana cedis respectively. The phones are kept in a specialized protected container of 10.1 square meters to prevent cracks and other malfunctions from vibration. In Nokia, Samsung and LG take storage space of 0.05, 0.1, and 0.05 square meters respectively. If a Nokia, Samsung, and LG costs 300 Ghana cedis, 1,200 Ghana cedis, and 120 Ghana cedis respectively, and the dealer has available 93,000 Ghana cedis to spend, what should be the optimal mix of phone types to purchase to achieve the maximum profit possible?
All right, so thank you, our friend here. So guys, from this problem, as we've been doing, this is a linear programming problem. There are 4 components you have to look out. This is just to refresh what we did last week. We agreed that you have to define the decision variables. After that, maximize the profit or the objective function, which is subject to the constraints. So after that, then we were able to formulate the non-negativity constraint. So can anybody, or let me quickly formulate it using my whiteboard, then we can make progress quickly. Cancel. Okay. So I know my decision variable. Let x1 represent number of Nokia phones to order. Let x2 represent number of Samsung phones to order. Let x3 represent number of LG phones to order. Then by this, I come to my objective function. Objective function, we are told that the firm want to maximize profit. So we say that maximize Z will be equal to the respective profit value. For Samsung, we are told it will, the unit profit is 100. So I have 100x1 plus 300x2 plus 50x3. This is subject to our constraints. And we have a space to ensure that these phones that are purchased are occupied. So we have, let's say, storage. Let's name it as storage. Storage or space, whichever one sounds good for you. We are told that a Nokia will cover 0.05 square meters. Samsung will cover 0.1 square meter. Then LG will cover 0.05 square meter. And we have a space available space to protect them. So less than or equal to 10 square meters. Then we also have the budget to spend on the items. We are told that LG will cost us 300 to buy one. Nokia, that of Samsung will cost us 1,200 X2. And that of LG will cost us 1,200 one. We are told that available money to spend is 93,000 Ghana cedis. Okay, then our last one is the non-negativity. Non-negativity, which is to say that we know X1, X2, X3 is greater than or equal to 0. Yes, guys, those who are chatting, please stop the chatting. Thank you very much. All right, so any problem so far? This is the LP modeling. You either ask me a question or you pay attention. Stop the chatting. Any problem so far? Okay. If we don't have, okay, yes, Patience, your hand is up. Quickly ask your question, please.
Okay, sir, please. I don't get the storage. I don't get how you formulated that.
No,
okay, 10.21.
You don't get.
Is how you multiply the 0.05 by 3?
By 3.
I can see times 3 there.
Where is 0.05 times 3 somewhere?
Yeah, the storage or space equation is just from
it is X3, sir.
X3.
You are not seeing or have written 3, please.
I can see 3.
You can see where is 3? It's 0.05 x1 plus 0.01 x2 plus 0.05 x3 is less than or equal to 10.1 square meters.
Okay, thank you.
Okay. Any question again? Yes, is it the same Patience? All right, so let's make progress. So at this stage, we can, all of us in this class, we should be able to formulate an LP problem, okay? If the problem is linear programming, we can use the modeling to formulate it. Now, as we've been doing, after the formulation, our quest is to find the determine the decision variables. Then after getting the decision variable, we should be able to know how much profit we are making in this problem, since it is a maximization problem. Then how many spaces are allocated, as long as the space availability for these phones are concerned. Then if I know that per my budget, how much will I spend or have I spent on each of these items? And we said we can use matrix or we can use graph, and we are introducing ourselves to the computer solution. Obviously, this is a 3 decision variable problem, so graph is out. Either we are using our known matrices or we use the computer solution. So I am going to model this whole formulation here, everything into Excel. Then when we are done formulating, we have to now solve using one of the Excel applications or the data analytics tool called Solver. So let's pick an Excel sheet. Excel sheet here, good. All right. And we are going to do the same way we have modeled. We started by modeling our decision variables. Okay. So in this case, when you open your Excel sheet, there are cells. Okay, so if I want to start from cell A1 or row 1 or row 2, it still doesn't matter. You just have to know exactly where you are modeling in your cells. So we have decision variables. So let me enter here our decision variables here. Good. Our decision variables are made up of what? We have Nokia, Samsung, and LG. These are the phones we have. Then we need to understand that we want to know how many of Nokia phones we are going to what? Sell. How many of our Samsung we are going to sell, and how many LG we will be selling. In that case, let's come to row 2. And in row 2, cell A2, I'm going to enter a number to order. Okay, number to order. Please note that we don't even know the number to order at this stage. And that is the problem of the day. And we've defined Nokia to be X1, Samsung to be X2, LG to be what? X3. Now, Excel understand numbers. Okay, so we can't come and enter X1 here, X2 at this point, and X3, since they are unknown. So what is required is that we can initialize our solution, our initial solutions to be 0 for each of the phones. Remember, we've also indicated that for decision variables, they are non-negativity. It's either we are placing an order or we are not ordering any items at all. So instead of stating X1, X2, X3, we initialize them to 0, 0, 0 as our initial solution, because we don't know at this point how many of these phones to order as the problem states. Good. So what I've done here now, I have done my decision variables. I've modeled the decision variables. Then we are also giving further information about the unit profit or the unit selling price for each of these items. So in row 3, in cell A3, I will enter unit profit for each of them. Now, the thing about the modeling is an art. You can decide whichever cell you want to do your modeling. It's so that won't change the results of your outcome. Just that you have to know in each cell which information, which data do you have there. So unit profit for Nokia, we are told Nokia is 100. That for Samsung is 300. And that for LG is 50. Good. So I need to, again, once I know my unit profit, one of the other components says that we should indicate our objective function. And we know our objective function here, we are dealing with what? Profit maximization. So I can come and either type here total profit, or I will type here my objective function. Let me just enter it this way so we can. What is my objective function? From what we modeled, we agreed that X1 times its unit profit, X2 times the unit profit, then X3 times the unit profit. Therefore, to find my total profit in here, let me type here total, just let me write here total profit so it doesn't confuse anybody. I know my total profit is the addition and multiplication of what? The unit profit, the total profit for Nokia plus total profit for Samsung plus total profit for what? LG. Now, I need to indicate in my Excel sheet what that information seeks to. So in cell B5, I've entered equal to, my total profit is equal to what? This unit profit here times the quantity that we don't know, okay, plus again my unit profit for Samsung times its total quantity we don't know. This plus my unit profit again times the quantity we don't know. If I do this and enter and press the enter key, I'm getting a result of what? My value is what? 0. Sorry, let me delete this guy here. F4. Oh, okay, so F4. All right, so what you see here is the formula for the Excel sheet, and that represents my total profit. Okay, it's just to say that the unit profit times its equivalent quantity plus that should give me that. Now, if you have more unit profit and more number decision variables, you may continue to do this all through. We can use a function in Excel to just generate the profit, the total profit. So instead of doing all this, I'm just going to type in some product because it is multiplying and adding. If I click on some product, this function appears, and I know all my decision variables value are multiplying and adding all my unit profit value. Again, when I enter 0, when I enter, I'm getting 0. We are getting 0 because the initial values for the decision variables, we've initialized all of them to what? 0. That is why we are getting the values what? 0. Then we have done 2. We've done our decision variables formulation. We've done our objective function formulation. The next one is our constraints. Okay, and as we model, we said we have what? Space, or we have storage, whichever way you want to. Space or storage, okay? And we are told that we are going to use 0.05 square meters for Nokia. So right under Nokia, I will put here 0.05 square meters. 0.5. Then I'm also going to use 0.1 square meters for Samsung and 0.05 for that of LG. Then we are told what is available. So I'm going to name cell F6 as available, okay? We know available square space is what? 10.1. Then I will write here utilization because we must know how many square space we have utilized at the end of the day. Then when I'm done, I come back to budget. Let's name it budget. The money you want to spend to order those items. We are told that it will cost us 300 to order a Nokia, 1,200 for LG Samsung, and 120 for LG. We are told that there is an amount of 93,000 to use to what? Spend. If these are all your constraints, you model them as such in Excel. Then please note that the constraint for storage is a function. That's a straight line, which is 0.05x1 plus 0.1x2 plus 0.05x3 is less than or equal to 10.1. Means that if we are able to find the values for that is the values for the decision variables. If we multiply each of the value times their respective allocation, that is their coefficients in the constraint, it should tell us exactly how many we have what utilized. That is why I have on this cell E6, I've named it as what? Utilization, which also means that if I want to know how many we have actually utilized, then I have to multiply again the unit, the total, each value that has been utilized times their corresponding allocations. So I'm going to have again some product as is indicated in our solution. I know these are the decision variables values I don't know yet. Then these are their respective what coefficient. Multiply, add, enter gives you 0. The same applies to that for budget. Also, I know these are my decision variables values times their respective coefficients allocated. Also, we are also getting 0, 0 here because, as I said, we have initialized our solution. Since we don't know the number to order for each of them, we initialize them to 0, 0, 0. Okay, so that if we are able to solve the problem, we should find solution to the problem that we seek. Let me highlight these guys here and see what will happen when we provide solution to our problem. Any challenge again? So what I've just done here is to model this formulation here. So I started with the decision variables. Then I came to the objective function. Then I've done what? The constraints. What Excel understands is the kind of data that you input that will give you the results that you seek. So any problem so far, so we can go on. Please, sir, can you go over again? All we are trying to do is that, yes, Patience Amma Mensa, yes, ask your question.
Sir, please, can you go over the utilization part again, where you had the 0, 0, 0?
Okay,
how
so
you did the formulation? I don't get it.
We know already from our, this is the formulation. We know that for storage is 0.05x1 plus 0.1x2 plus 0.05x3 is less than or equal to what? This guy here. So technically, if this is what I have is available, then if I'm able to find the values for the decision variable, this multiplication and addition here should tell me how many space I've actually what used. Same applies to budget. If I'm able to know the quantity for X1, number to order for X2, number to order for X3, by addition and multiplication, this side to also give me what? My usage. So usually we say that when you look at these two straight line, this straight line here, this could be referred as your left-hand side of the constraint. And this is your right-hand side of the constraint. Your left-hand side indicates the usage. What have you actually consumed from the resource that have been given? It is the same principle we are applying in the modeling. So when I come here, I'm saying that, let me delete this guys here, 0 here and 0. We are saying that to know what is utilized, I know this is the allocated space given to what? Nokia. What will be the total space for Nokia is going to be what has been allocated times the quantity that I have ordered. That will give me what? The total utilization similar to this. So when I multiply and add, I should get my utilization. So we said this should be equal to, again, we are using the Excel function called the sum product. So I type sum, it shows up, I select it. When that is done, I know again, it is my quantities here that I don't know, they are multiplying and adding their respective what? Allocation. That close the bracket should give you what? 0. Same to budget. Some product also this way. These are my quantities and these are my respective what? Allocation. Close the bracket and enter. That is why we are getting 0, 0. The same applies to total profit. We already know this information. We know these guys too, and we know this guy too. So the new thing we are bringing in is the total profit function and the utilization function. Those are the only thing we yet to know. And the total profit, we also said that we are looking at what? Oh, why do I keep pressing shift? We are looking at this guy here. Total profit is the quantity to order times their respective what? Unit profits. So we said sum product, and that gave us again 0 because we have initialized the number to order to be 0, 0, 0 because we don't know how many we are ordering. Once you do this and your modeling is okay, let me say that if you don't insert the right formula, especially at the total profit function cell and the cell for the utilization, you may not get an accurate what? Solution. When this is done, I can now go and look for the appropriate data analytics tool from Excel to solve this problem. So please, can the document recovery part be? So I can now look at this and solve my problem. So for those of you who want to do this, you look for the data analytic tool here so find home, insert, draw, page layout, formula, and data. When you click on data, you move to extreme end towards your right hand side. You see data analytics and what? Solver. I have already installed Solver in my Excel sheet. If you come to this point, if you have not installed Solver, you go through step-by-step process to install the Solver. Therefore, if you are using Windows, depending on the type of Windows you are using, the Microsoft application you are using, when you come to File, you click on File, you go to Options. When you click on Options, it opens a new window called the Excel Options. Then you come down all the way to add-ins. It means that you want to add in something in your Excel to appear on your Excel sheet. So when I click add-ins, it opens another window that gives you have name, location, and type. Okay, you will see if you've not done anything active, if you've not installed any active application, this place may look nil, or it may still show up. So you select, we'll be using these two, Analysis 2-Pack and Solver add-ins for the rest of the semester. So I have installed these two already. So what you can do is to click on each one of them. Okay, so if it's Analysis 2-Pack, you click on that. Then there is a button here, which is Go. You click on Go. Go now, go around to install whatever application you are trying to include. Then Solver add-in, you do the same. You click on Solver add-ins. You click on Go. When you click on Go, it also comes through the processes. So when you are done and you click on data again, you will see data analysis here and what? Solver. Okay, so I have my Solver here. I click on Solver. It gives me a new window. Now from the new window, you are expected to have 3 main spaces that should be free of any entry. Okay, so you have the first one as the set objective. Whatever is here must be erased. Then I come to by changing variables. There is nothing here. When you come to subject to the constraints to, there shouldn't be anything here. What solver understand is that whichever data you input here will automatically be generated as the output for you. So your input gives you your output. Therefore, at the set objective here, set objective is talking about your objective function. We are only going to select the cells that have our formulae. Okay, so there is an objective function formula. There are formulae for the constraints as well. So when I come here, I put my cursor in this space and select the cell with my objective function formula, which is in B5. B5. So I click on B5 to select that. If you select any other cell or an array, when you finish solving, you may be getting errors. So ensure that the set objective here is filled with the formula or the objective function formula cell, which is in B5. That's what we have selected. Then when you come to the next, it is your objective function is either maximizing or minimizing. By default, solver will select maximization for you. If it's a minimization problem, you check the minimization button. So by default, it's maximization. That's our problem, is maximization. So we select maximization. I don't know where the maximization is. Look, guys, I'm recording this. If you don't understand something, you raise your hand, I'll call you. But to disturb, I will remove you from the group and you can't join again. Yes, Francis, your hand is up.
Yes, sir. Why? Because like for the question and this thing, the formulation, the objective function is 100 is 1 plus 300. Why is that like we are using the?
I'm listening. Why are we using
the total profit as a objective function instead of the 100 is 1, 300 is 2? Yeah.
Okay, Francis. We wrote the function as what? 100x1 plus 300x2 plus 50x3, right? If I multiply and add all of them, what value will it give me? That is the profit we are looking for.
All right.
Yes. So it's the same thing we have modeled here to say that 100 here times x1, 300 times x2, 50 times x3 will give you the total profit that you are looking for. I hope that is clear. Yes. Okay.
Yes, please.
Yes, patience. Yes, patience. Okay, let's continue. Patience, is your hand up? All right, so as I said, by default,
no, please. It's not
by default, solver parameters will select maximization for you. But if the problem is minimization, that is, you are dealing with cost, you check on the min button. Good. Then the next one, that's the next space we have available, is by changing variable cells. Which of the variables here do we have that will be changing? It is the Nokia, Samsung, and what? LG. Again, we don't know their values, okay? But we initialize the values to be what? 0, 0, 0. So this space here must also have the data with the quantity of the variables that we don't know. So in row 2, we have your number to order. But because we are dealing with numbers, we have for Nokia is what? It's in B2. Samsung is in C2. LG is in D2. So we can select this row where we have our 000s into the by changing variables cells. Please note that. The last one is the subject to the constraints. We are dealing with our constraints. Now it is clear that there is nothing here. So we want to add our constraints into this space as well. So when I click on add, it gives me a small window here as it appears. You have two main or three spaces. You have the cell reference, the equality or equal to reference section. Then you have the constraint. The cell reference would have your utilization cells, and the constraints will have the available cells. So under utilization for storage, I know storage utilization where I entered or indicated my formula is in cell E7. E7. So I'll come and select E7 here. Now, when we're modeling, we are saying that 0.5x1 plus 0.1x2 plus 0.05x3 is less than or equal to what? 10.1. So in this column where I'm moving my cursor, when I check on the bar here, the bar drops, gives me what? Less than or equal to, greater than or equal to, integer, binary, and different. Our focus at this stage is on three main inequality and equality signs: the equal to or equal to, less than or equal to, and greater than or equal to. So per the problem I have, it's less than or equal to, so I have to select less than or equal to. And again, by default, Excel will already select the less than or equal to for you, unless the constraint has a greater than or equal to sign. That is when you change it. Then when I come to my constraints, okay, I have for available for storage, the value is in what? Cell F7. So I select cell X7. Sir, please, when this comes in exam, will you be giving laptop? Some of you are so fixated about exams. You think this thing is just exams, that's why I'm taking my time to teach you? You are too fixated about exams. Forget about, let's find a solution. Then we'll tell you that what you have to do. Okay, so we have done or input the data for storage. The next one is to also input the data for budget. So I click on add. Okay. Then again, as I repeated, cell reference is for utilization, and for budget, it's in E8. So I select E8. Again, our equation was less than or equal to. Then my constraint is what? 93,000 for available in cell F8. So I select that one as such and click add. Then the last thing you include in the constraint is your non-negativity. But we said all the decision variables are greater than or equal to what? 0. So therefore, I know my decision variables row, they are in B2, C2, D2. So I select all of them. Then they are greater than or equal to 0. So I change this greater than or equal to what? 0. I click on what? Okay. Once you are done, you should see this data that you have what? Input in your solver parameters. This is for set objective. This is for decision variable. These are your constraints. Then at this point, we want to solve our problem. Now you come to select a solving method. Again, we have GRG non-linear. We are dealing with a linear programming problem. So I come here and change it to simplex LP. I click on Simplex LP. Once all these are satisfied, I can now what? Solve the problem. So I'll click on solve here. If I click on solve, something or there should be some changes that you should see. Do you see any changes so far? Do you see anything changing here? Do you see any changes from our Excel sheet now?
Yes, please.
Yes, Cameron, what do you see?
So I can see that the solver has given us the solution to the decision variables.
Okay.
So yes, number of Nokia phones. So should I continue?
Yes, please go ahead.
Okay, so the number of Nokia phones to order is now 94.
Okay.
For Samsung is now 54. And then we are not going to order any LG phone.
Okay, yeah. That's great. Who else? What do you see? Cameron, thank you very much. Who can also help us with something? What do you see from the output? Any hands up? Yes, Kenny.
That profit figure has been given. That's 25,600.
Okay, so that has also changed.
Yeah.
Okay. What again has changed? Priscilla Kwashi, can you help? What has changed?
Utilization.
Okay, the utilization constraints. That for space is 10.1, and then the budget is 93,000.
Perfect. So you see, instead of going through the hula baloo of using matrix or matrices, the computer just simplifies the problem for us. So let me put here, let me just write here left-hand side, as I said, and this is my right-hand side. Okay. So typically, let me see some charts here. Please, can you go through that part again? I was lost a bit. What were you lost? What were you lost? Be explicit with your questions. Emmanuel Ano, yes, any question? Emmanuel Ano, any questions?
I wanted to contribute to what you are saying for the utilization and the available figures. We can see that they are binding because the left-hand side is equal to the right-hand side.
Okay, you have done. That's good. That's a smart choice. I'll come to that place very soon. Thank you. If you have a question, Emmanuel, you just spoke. Sorry, Entry Williams. Is it a question or suggestion or contribution? Emmanuel William Entry. Okay, so if you are not talking, Patience Amma Mensa, is it going to be a question?
A question, please.
Okay.
It says I was following. I'm also doing mine on my laptop here.
Okay,
and
that's good.
At the my figures are different.
What did you get?
And so please, when you go to the last, when you're adding the constraints, the last part,
yes,
the non-negativity part.
Okay.
What did you enter at the constraint part?
Non-negativity constraint.
Yeah, you entered for the cell reference. You entered the
cell reference will be
the number
of
of
utilization is. Are you the non-negativity?
Yes.
You select B. Yes. You select where you have your zeros together. So B2, yes, C2, D2. Select all of them together. Then remember they are greater than or equal to 0.
Yes, please.
So you change from less than or equal to 0 to greater than. Then the last one, that's the value, is 0.
So I type 0?
Yes, you type 0. You have to type 0 because we indicated in our non-negativity, x1 is greater than or equal to 0, x2 greater than or equal to 0, x3 greater than or equal to 0. So after you have selected your, this is it. Let me just come here. Greater than or equal to 0, then the constraint right-hand side should be 0, then you click OK. Have you done that?
Yes, please.
Then you come and change. What do you have as a solving method? Look for simplex LP. Change it to simplex LP. Then you now solve it. While somebody is asking for important question. Who is that? Who is that? Is that Ebenezer? Wow, amazing. Oh my goodness. So are you okay now? Then you click on solve.
Yes.
Click solve.
Yes, please.
Now, what do you have the same changes now?
No.
So
please, I think I did them. No, it's still not giving me the same answer.
You've done something wrong, okay? I'll send the video for this.
When okay.
When you what?
If I change, let's say I change the 93,000.
Yes.
The 93,000. I mistakenly wrote 9,300. If I change it, will it have
so just
effect on
go
all
and change. Just go and change it to 93,000. Okay. Then click on your solver again. Once all the data you've entered here are correct, you click on solve. It should change. Okay. I'm trying to help you, so do this quickly. Don't hijack the class. Okay. Since you are the only
please, I'm going to solve
person, click solver. Do you see
please
now?
Damn.
Now I want you to click on check. You will see reports. Click on answer and click on sensitivity. I'm coming there. Check answer.
I can't see reports.
Solver results. Don't you see a window appearing on your sheet? Solver results.
I closed it earlier, so I should go to solve again and get that
just
option.
click on solve. It will come.
Okay. Yeah, I can see it.
So select answer and sensitivity and click OK. It will be showing down there. You see sensitivity report and answer report.
Yeah.
Okay.
Yes,
so guys, at this point, we've used Excel
I got it.
to solve. Thank you. So
Thank
mute yourself now. We've used Excel to solve this, but this is not the report we want to analyze. I just want you to understand that. The report we are going to analyze, I'm just going to look at the sensitivity report. Okay, sensitivity is just saying that what if there are some changes in your initial modeling? What will happen to your profit? What will happen to the constraints? What will happen to what? The number to order. So I'm going to select sensitivity report. You should see this report showing. Let me increase it. This is too much. Okay. All right. So from the solver output, the sensitivity report gives us two main tables. We have the variable cell table. Let me highlight that one and give it a yellow color. The variable cells table from the report. Then we have the constraint report. Let me give that one my favorite color, blue. Okay, good. So this is what you have, and this is what we have to interpret. So typical of any application software or a software that you use for data analysis, you see the output and you have to interpret the output accordingly. So I'm going to start with my variable cell table, then come to the constraint. In a variable cell table, you will see information in each column. So you have cell column, which tells you where you did your modeling. It's just to say $B, $2. You can find Nokia, number of Nokia to order in this cell. So we have cell, we have name. The names is simply to say the decision variable names that whatever you model in Excel as your inputs, that's the output we are seeing here. So that is not a big deal at all. These are the names. Number to order for Nokia, number to order for Samsung, number to order for LG. Then in the next column, you have final value. Final value. Now the final value in the variable cells is the information that relates to the actual quantity that we are ordering or we are making. Okay, so when you look at number to order for Nokia, you have 94. The 94 here tells you exactly how many you are ordering for Nokia. Then for Samsung is 54, how many you are ordering for that? LG is what? 0. So we can conclude to say that the phone dealer should order 94 Nokia phones, 54 Samsung phones, and 0 what? LG phones. In fact, the final value you see here, it is what we refer to as the optimal solution. Remember when we're trying to use the graph, we said that there could be feasible region. And in the feasible region, you have feasible solutions. But it's only one of the points that we are interested in, which is the optimal solution. And we said for maximization, the point that gives us the highest profit is our optimal solution. So if I ask you to identify the optimal solution from the solver output, the optimal solution is the final value in the variable cells. So our optimal solution is that the phone dealer should order 94 Nokia phones, Samsung 54 Samsung phones, and none for LG phones. This is your optimal solution. Please note that. Then I'm going to the next column. I'll jump here and come to this column. I'll do the reduced cost later. The objective coefficient, what do you see? Is the information you already know. You know that your objective coefficient value for Nokia was 100 in your modeling. That for Samsung was 300, and that for LG was what, 50. So the column here is just to emphasize the unit profit you entered. That's why you see objective coefficient. Therefore, if I want to know the total profit, having in mind my optimal solution, I'm going to say that my total profit is therefore going to be 94, 100 times my 94 to order plus 300 times what? 54 to order plus 50 times what? 0. This is the 25,600 you were seeing as your total profit. So the corresponding total profit or the objective function value for the optimal solution is determined by multiplying each of the coefficient times their corresponding final value, which will give you 25,600 as your total profit. Then we have the next two columns. We have here allowable increase and allowable decrease. By the name, is suggesting that allowable increase is saying that you are giving some space in terms of increasing your profits, the unit profit. Because of competition, a lot of people are also ordering, or there are dealers in Nokia who are also competing with your customers. So if your unit profit is 100, okay, and because of competition or the demand for Nokia phones is going high and you still want to make profit, you are allowed to increase your profit by 50. Okay, allow to increase your profit by 50. Means that you can increase your profit by 10, 20, 50, 45, or 40. You cannot go beyond 50. That's the allowable amount you are given to ensure that you still attain a profit given the demand that is going up. Remember when they increase petrol, the Ministry of Transport will be telling GPRTU, the peg, you cannot go above maybe 50 pesos. That is their allowable increase so that people can still board their cars. Good. So that is the essence for the allowable increase here. So that my profit may go up to 150, 100 plus 50. And I'll still be making somewhat profits. My new profit can attain up to 150 cedis. Same has to deal with the allowable decrease. But allowable decrease also says that if ever, because some people are taking your customers based on pricing, you are allowed to reduce your price by 12.5. Okay, that is why the what if question comes in. So what should you do if competition is high, but you still want to maintain your customers? Decrease your profit by 12.5. Means that you can reduce the profit by 1 cedi, 2 cedi, 3 cedis, 11 cedis, up to 12.5 cedis. Means that the lowest I can reduce my profit is 100 minus 12.45, which is 87.45. This is the lowest you can reduce your profit. Yes, Francis.
Yeah, hello. Yes, sir. So the 50 and the 12.5, are they in currency or in numbers?
They are, as far as the unit profit is concerned, they are in currency numbers.
All right, okay.
Patience, yes.
So please, can you explain the, I can't see it. I didn't get the allowable increase.
Okay, so Antonia, solver will show you the values for the allowable increase and allowable decrease. You don't have to do anything. That's the issue with using the applications to provide your values. The allowable increase, I said, we are going to explain the allowable increase, the allowable decrease with respect to the objective coefficient. That is the unit profit. Allowable increase says that in case demand, I'm just giving some theoretical explanation or practical ones. In case demand for Nokia is still surging up, and you know in Ghana typically, or by the forces of demand and supply, okay, the higher, when we say the higher demand, the highest, I've forgotten my economics a bit, but basically once demand is increasing, it means that if the product is, let me use, is it an inelastic demand or perfectly inelastic demand? Once the demand is still increasing, people may not be too much concerned about how much you are pricing. Okay, they will still buy. However, the solver output or the results we have here says that although we can increase our profit, we are allowed to increase it up to 50. We are allowed to increase it by just 50. We can increase it by 2 cedis, 3 cedis, 5 cedis, but we cannot go beyond 50. Therefore, the highest profit we can increase Nokia to is 150. That's what I was trying to say, that it is the 100 plus 50. That gives you 150. Allowable decrease also refers to or indicate that anytime you want to also reduce, if people are competing with our product, or you want to induce your customers to buy more, you can, let me say, discount your product, reduce the price, and you're allowed to reduce it by 12.5, means that you can't go below 12.5. If you still want them to increase or demand your Samsung phones, or you still want to sell 54 Samsung phones, sorry, 94 Nokia phones, you are allowed to reduce it by 12.5. That is the statement to say that the demand is inelastic. They will still buy even when the price is high. The lower the price, the higher the demand. But sometimes it's not always true that the lower the price, the higher the demand. I'm sure you've been told, Maureen, when you have what luxury product, it's not always the lower the price, the higher the demand. I don't want us to do economics here. Just that I'm trying to explain some of the empirical evidences that can be obvious to us. So please note this allowable increase and allowable decrease. Now, if you understand these two perfectly, yes, Amwako Peter. Peter Amwako. Yes, Peter, ask question. Go on.
Okay. Hello.
Yes.
Be the effect when we increase beyond the allowable increase.
I'm coming there. We've not gotten there. I need people to understand before I come there. Any other question? So that I'll go to. Can you mute yourself, please? All right. So, yes, patience.
So please, did you skip the reduced cost part? Because I don't remember you explaining.
I've not even tackled there. I will come there. Why are you? I will come there. I'm not done with what I'm explaining. Please be patient. I kind of say,
and then one E.
Bojidi, my friend, Bojidi will come there. David Asante, yes, David, ask your question.
The allowable decrease to the number to order for LG. I see 1E plus 30. How do you interpret that?
Okay, so it is 1 exponent 30. Okay, it means that it's an infinity value. Okay, you are looking at 1 0 0 0 0 0 0 0 0 0. So you can increase LG, you can decrease LG by what? Any value. An infinity means that as long as the decrease for LG is concerned, you can go ahead. But you can also sometimes see 1E minus 30 instead of saying plus 30. It also means that 0.0000 all the way to what? 30 zeros. That's the interpretation. I hope that is clear. Okay. So I want to calculate something for you. Since we know the whole idea about allowable increase and allowable decrease, there is what we call lower bound and upper bound. It's just to further explain something to you. For the lower bound, as we said, that is the lowest value we are allowed to reduce our profit to using the allowable decrease. So for Nokia, I know it's 100 minus what? 12.5, which is 87.5. Okay, then the upper bound is 100 plus the 50, which will give you what? 150. So technically, you are within this boundary between 87.5 to what? 150. Either to reduce to this guy, to this value here, or to increase it to what? That value here. That explains further to say that with your allowable increase and allowable decrease, you can compute for the lower bound value and the upper bound what? Value. Same applies to Samsung. If I want to know my upper bound for Samsung, it is a 300 plus this guy here. And for lower boundaries, 300 minus what? 100. Similarly to what? LG 50 plus 20, 50 minus that infinity what? Value. Okay. So that explains allowable increase and allowable decrease. Then somebody is asking us to, what about reduced cost? Now, for reduced cost, you realize that the decision variables with a non-zero values, their respective reduced costs are all zeros. But the decision variable with a zero value, its corresponding reduced cost is also what? None what? Zero. It's either positive or what? Negative. And for maximization problem, mostly the reduced cost for a zero decision variable value is negative. Is negative. So what is reduced cost? The reduced cost is the opportunity cost in introducing an item or introducing a decision variable value with what? Zero value. Means that if the firm decides that although demand for LG is zero, and they still want to introduce or force their way out to make sure that maybe there is a small portion of customers who still, we call them the customers who don't care. They are the lovers of LG. Although the profit for LG is not too good in the market, we still want to supply something for this group of what? Essence. If we are doing that, there is going to be an opportunity cost in either reducing the quantity for each of either Nokia or Samsung, so as to pave way for LG items to be what? Sold. So that is all the reduced cost explains. Is the opportunity cost in introducing a decision variable with a zero final value. So please note that. That is all about the reduced cost. Yes, David Asante, I see that your hand is up. David. Yes, David. I'm not sure you want to talk. Okay, so let's proceed. So that's explain reduced cost. So please note, in the variable cells, these are the explanation we can provide based on the information we see from the reports that we have here. Yes, Cameron.
Yes, sir. So on the reduced cost,
yes.
After you explained that of the LG, the negative 20, is that to say that if you produce, you order just one LG phone, you'd have to forgo 20 of either Samsung or Nokia?
No. That is the opportunity cost. You should know that it is the alternative is to say that it means that our profit is going to be affected by a certain value, but it's going to cost us like 20 more, because if we are refusing or we are saying that we are not ordering anything for this guy and that guy, if we are saying that we have to pave our way through in order to bring in something here, the opportunity cost may affect that of the items that you have there. The cost may be more than the 20 that you see there. But just to explain the arbitrary value on how much it's going to cost you if you intend to bring in that item, just because you still want to produce or make them possible for customers to demand. With a zero cost, okay. So, all right, so somebody was asking, so sir, what happens when your increase, that's the allowable increase or allowable decrease, goes beyond what you are allowed to, okay? Means that you are moving below the lower boundary or you are going above the upward boundary. What are going to be the implication? What if you increase Nokia by 60 or 55 instead of what? The 50. What if, or what happens if you reduce the profit more than 12.5? What are the implications? The implications are that, one, if anytime we increase our unit profit more than the allowable increase, two things will happen, two implications. It means that, no, let me first indicate, if we are increment is within, let's look at if they are within the allowable increase and the allowable decrease. That is, they are within the lower boundary and the upper boundary. It means that your optimal solution will not change. Means that if I increase this by 45, I will still demand, or the total number to order will still be what? 94. Samsung will still be 54. LG will still be what? 0. Means that your total profit is going to what? Change, because the unit profit here will be changing, but the optimal solution will still remains the same. So two implications: optimal solution will change, total profit, optimal solution will not change, sorry, total profit or the objective function value will change if your increase or decrease is within the lower boundary and the upper boundary. That is the first issue. Then the second is that, what about if you go beyond your allowables, you go beyond your allowables? If it is more than 50 or less than 12.5, your optimal solution will change and your objective function value will also change. So please note that. This is what I'm trying to indicate here. Why sensitivity report? Good. Good. What are we here? Okay, so this is one. Changing the objective function coefficient for a variable. As long as the profit of Samsung lies within the lower boundary and upper bound, the values of the variables in the optimal solution will remain unchanged. It will still be 94, 54, and 0. But your objective function coefficient will change. Means that effectively your total profit will also change as such, will change, but the optimal solution will not change. We can draw similar conclusions for Nokia and LG. If we are increasing our profit for Samsung by certain values, and it lies within the objective, it lies between the lower bound and the upper bound, we will conclude to say that our optimal solution will remain unchanged, but the total profit will change. Then, as I was talking about the reduced cost, forcing a variable which is currently 0 to be non-zero. For variables, the reduced cost column gives us for each variable which is currently 0 an estimate of how much the objective function will change if we force the variable to be what? Non-zero. So reduced cost, as I said, is the opportunity cost for that variables that we are trying to force them to be non-zero. Okay, what again? All right, so that explains the first table, or the, yes, Eunice also, please ask your question.
Certainly, a case of the allowable increase, maybe being 55.
Yes.
Which of this one will it affect? The 100 or the 94?
It may affect the whole solution. Let me look at this. Okay, so you said we should make this 55. So let's do this 55. No. Sorry. So let's do this 0. Let's go back to our initial problem, 0. We are increasing it by 55, means that 155, right? If I do this and come back again to solver, data, solver, everything remains the same. What has changed? Can anybody help? What has changed? You know that the number to order for Nokia is now what? 202. Samsung is 0, LG is what, 0.
Yes.
Yes, it will affect the entire solution. That's why we say that the optimal solution will change. How that is okay. The optimal solution will change. Yes. Maimuna, do you have a question to ask? No, please mute yourselves if you don't have any question. Let's look at the next table. Somebody was talking about binding and non-binding constraints. So let's come there. Adiza, is it Maimuna? Do you have a question? No. Okay, so let's come to the next table, which is the constraint table. And just as we were doing for the variable cell table, you see the cell, their respective name. So here we have space storage utilization and budget utilization. Then we also have final value for the constraints. But this final value is our utilization. So I'll name it the left-hand side, or utilization, that column. Then we have shadow price, I'll come there. Then we have constraint right-hand side. It's also the available. Okay, so this constraint side is simple to interpret. Okay, you realize that the left-hand side for space and storage is 10.1. That is the utilization. And what we had available was also 10.1. It means that space has been fully utilized. Let's look at budget, also 93 for utilization or left-hand side, and 93 for what? Constraint, that's the right-hand side available. Based on the final value here and the constraint right-hand side here, we can determine which of the resources or which resource is binding and which resource is not binding. And we explained that the left-hand side, if it is equal to the right-hand side, then that resource is a binding constraint, means that it has been fully utilized. If the left-hand side is either less than or equal to or greater than or equal to or not equal to the right-hand side, we refer to that resource as non-binding. Please note that. So from the report, we should be able to identify all binding constraints and non-binding constraints. Then again, the left-hand side and the right-hand side should tell you which resource is slack resource, we talked about this, and surplus resource. We refer to the slack resource for a constraint when the left-hand side is less than the right-hand side. It means that we define slack resource as the unused resources, so that if I subtract what has been used from what is available, if the usage is less than what is available, then I have my slack resources. So I can ask you to compute the slack resources or compute the surplus resource. Surplus is when the left-hand side is greater than the right-hand side. So I've talked about 4 things here. What we can use the final value here and the constraint right-hand side to determine the binding constraints, the non-binding constraints, determine the slack resources, and the surplus resources. In this case, we will say that space utilization is binding. It's a binding constraint. Budget utilization is also or budget is also a binding constraint. Please note that. Then we have 2 columns again, allowable increase and allowable decrease. It's the same explanation as we did for the decision variables. What it means that if any time we want to increase our resources or decrease our resources, again, based on usage. For storage, we are allowed to increase our storage space by 5.4. So our upper boundary will be 15.5. My lower boundary is going to be what? 10.1. I'm allowed to reduce the space by what? 2.35. Please note that. And similar to budget, we can increase our budget by 28,200 or allowed to reduce it by what? 32,400. Then somebody is asking what happens to if you go beyond or goes above. Okay, it doesn't apply here. But what is important is that this column here, the shadow price is giving us an indication that at any time there is a unit change in either of the constraints, we are going to look at the replica effect on our total what? Profit. So a unit change in space, that is increasing space, will give us a unit profit of what? 1,000, which will be affecting our profit. So the shadow price is simply the unit change in the unit change in our objective function value as a result of a unit change in our constraints or in our resources. So therefore, for utilization, if I increase available space to 10 or 11 points, let me just say by 1, my total profit is expected to be changed by what? 1,000 cedis for each changes that I undertake. Again, we say that the shadow price explains the unit change in the objective function value as a result of what? A unit change in our resources. So mostly when you go to the labor negotiation and labor is asking for increment, the government is also looking at the effect. Is it going to contribute this so much profit? Or when production units are requesting that their raw materials, what they have there is not available, is not enough to produce, there should be some questions from management. If we should increase the resources, what will be the effect on the profit? Because everybody is looking at profit. What will be the effect? So for every unit risk of change in the resources that you are bringing, what is its contributing effect on your total what? Profit? And that is what the shadow price explains. On that note, that should give you the interpretation for the solver output anytime you use Excel to analyze your problem. Any questions so far? Any questions so far? Yes, any questions so far? Yes, Peter. Yes, Peter. Peter, please go ahead.
Yeah, please. So when we increase our the space, when we increase our, let's say, hello.
Yes, I'm listening.
Okay. When you increase our space by 2, this means that the effect on our profit
is
going to be 100 over there, or to be 100 times 2.
It's 100. We said a unit, so it is 100 times 2. Okay. That is going to be 2. Yes. Yes, Godfred O2. Godfred.
Okay, sir, please. I think my question is like the shadow price you saw with the change in the constraints, there was a very huge shadow price for the. Sir, please, can you show that? Yes, there's a so 1,000 change for just a unit change in the resource. And looking at the budget, that's a very small amount. So why are we seeing such a huge change with the shadow price in terms of
that should tell you, you see, okay, thank you. Let me explain. You see, that should tell you that the contribution from the resources that you introduce into, let's say, a typical production, okay, each resource has a contribution. So look, my question then is to say that between space and budget, if you are to increase any of these resources, which of them should management concentrate on? You are looking at the one that gives you the highest contribution to your objective function value. Therefore, between utilize the space and the budget, we can advise that at any point in time, we want to bring in more resources. We should concentrate on which of the resource will lead us to increasing our profit. That is why when you meet a typical production manager, they'll tell you they will do the add and subtract on their resources before they go into a production. Because some of the resources are very important than the others. In other words, when you are doing scale of preference, you need to check which of the resources you are introducing or bringing will contribute to a certain amount of value before you bring it to that. So from the solver output, this is typical to tell us that storage as a resource is more important than the budget allocation. So the guy who asked the question, this is a very important question you've asked. So please note that typical of even when you go to the energy ministry, NAPO will now decide based on the problem going on. Do they need more skilled labor, or do they need to go and buy more crude oil, the oil they use? Do they have to do more gas plant, or they have to bring in labor in terms of skilled in order to help us control this designer doomsday that we are going through or not? So that is a critical thinking to the resources that we introduce at every given point in time. So the gentleman who asked the question, please note, I may ask this type of question in the exams or in your evaluation. What will you recommend to management with reference to the shadow price if they want to introduce any resources? Which one should they consider? So these are the issues that we look at when we are analyzing the solver output. So thank you very much for that question. Any other question again?
Sir, there's a follow-up question.
Yes, a follow-up, yes.
Yes, please. So since that, you may ask us a question that relates to this. That we mean with the exam, we may have access to computers to work with, or we can even do manual calculations to arrive at such answers.
Okay, so I'm coming there. Thank you. So some of you don't have laptops. So if I ask you to go to the exam hall with your laptop, there will be chaos. Some may even carry their desktop to the exam hall. So you don't have a problem at all. What we are going to do at this stage is that we will give you the problem. We'll ask you to model them as we did in you use the, the writing the linear programming component carefully. Then I will tell you that the problem has been modeled using Excel, and this is the output. So you will get this output in the exams. Then I'm going to ask you 50 questions under these two tables, or 100 questions, or just some 10 questions. What is the optimal solution? That's the first question. What will be the corresponding total profit from this? How do you explain allowable decrease and allowable increase in the variable cell table? The next one I may ask you is that if the unit profit of Nokia is increased by 40, what will be the effect on the optimal solution and the total profit? Okay, can you explain the meaning of reduced cost from the table that you have there? Okay, so I'll be asking then when I come here, identify the binding and non-binding constraints, or calculate the slack resources, or calculate the surplus resource. Then I'll ask you to explain the shadow price. Then I'll ask you what would be your recommendation to management, or to whichever problem you have, what would be your recommendation for resource increments between or more than these three resources? Which one do you think should be introduced to, should we increase at any given point in time? So don't worry about the modeling aspect in exams. What you should worry about is how to understand the question, define your decision variable, define the objective function, define the constraints, define the non-negativity. Then I'm going to give you this output and I'll ask you to interpret the output accordingly. All right, Eunice, also your question.
Yeah, sir, please, I want